Hi everyone, this is Maverick Pua, the Chemistry Guru. Now in this video, we want to discuss the different types of acids and bases that we'll encounter in ionic equilibria and their dissociation in solution. Let's take a look. Now in ionic equilibria, an acid is defined as a proton donor, a species that can give up H+, and a base is defined as a proton acceptor, a species that can accept H+. For acids, we have two types of acid, a weak acid and a strong acid. So we have an example of a weak acid here, my CH3COOH. So in solution, what you will do is you will do a partial dissociation. So we use a reversible sign to represent this partial dissociation to give me CH3COO- and a H+. So because CH3COOH can donate H+, so CH3COOH is considered as an acid. And because it's a partial dissociation, it's a reversible sign, so we call this a weak acid. Now the counter ion form CH3COO- in the reverse direction because it can accept a H+ to form back my CH3COOH. This CH3COO- we call this a conjugate base of the weak acid. Now the word conjugate just means that this CH3COO- is a base with respect to CH3COOH. It's a conjugate base of that weak acid. It doesn't really tell us whether this CH3COO- is a strong base or a weak base. Now it's not possible for the conjugate base to be strong because if you're strong, it will drive the reaction backwards and this will be a full arrow and it will not be a reversible sign. So what this must mean is if the system is at equilibrium, then both species on both sides of this equation must be weak. A weak acid must give me a weak conjugate base. The next example of a strong acid, HCl. HCl will dissociate in solution fully. It's a full dissociation, so we use a full arrow to give me H+ and Cl-. So my HCl is capable of donating H+, so it's an acid. It's a full dissociation, so we call this a strong acid. Now for strong acid HCl, when it forms this counter ion Cl-, how will we quantify this Cl-? It is easier for us to say that since this Cl-, there's zero tendency for us to form back my HCl because this is a full arrow. So we just say that my Cl- is neutral. So what this means is a strong acid HCl will dissociate to give me a counter ion that is neutral. Now next for bases, we have two types of bases, a strong base and a weak base. Now remember, base is a proton acceptor, but when we write out in ionic equilibrium, usually we show the dissociation of my OH-. If you can form OH- in solution, then it's considered as a base. So if I look at ammonia, it's a partial dissociation, so this is a reversible sign to give me NH4+ and OH-. So my ammonia is a weak base. Now how should we call this NH4+? Because in the reverse direction, this NH4+ can react with this OH- and donate a proton to OH- to form back my NH3. So the nature of this NH4+ is actually acidic. So we have it here, NH4+ is the conjugate acid of ammonia, a weak base. And since the reaction is reversible, so the dissociation involving this conjugate acid is also partially dissociated. So in terms of nature, what this must mean is my NH4+ is also a weak acid. So what this means is my NH3 will dissociate to give me a weak conjugate acid. NaOH is an example of a strong base, fully dissociated to give me Na+ and OH-. So since this is a full dissociation, and we say that this is my strong base. Then how about the nature of my Na+ that's being formed? Again, because Na+, there's no tendency for Na+ to go back to my NaOH because this is a full arrow, it's not a reversible sign. So it's easier for us to say that Na+ is neutral. So my strong base will give me a counter ion that is neutral. So in summary, this is what we need to know in ionic equilibrium. This concept is very fundamental. My weak acid will dissociate in solution to give me a weak conjugate base. My weak base will dissociate in solution to give me a weak conjugate acid. Strong acid, strong base, when it dissociates in solution, the counter ion forms are neutral. I hope you find this video useful. Please subscribe to my YouTube channel for more weekly video lessons. That's all for this video. I'll see you next time.